I'm Don DeLoach, and I'll be conducting the next session. Hope everybody's having a good day. Hope everybody is enjoying the summit. I will tell you, this is new to me, so this is an interesting format, and I hope that this can provide some value. I'm going to talk a little bit about really a market progression in IoT, really looking at kind of where the market has been and where we expect it to be going and why, with a particular emphasis on data and the leverage of that data. So again, I'm Don DeLoach. Just a brief bit of background. I am a software CEO. I've been doing this for really 18 years now. My last real job, quote unquote, was in an executive role at Sybase back in the late 90s. So I left Sybase in the late 90s and became CEO of a CRM company, and then called Ucentric, and then in 2002 became CEO of a complex event processing company called Aleri that, interestingly enough, we sold to Sybase in 2010. And then from 2010 until recently, I was the CEO of an analytic database company called InfoBright. At InfoBright, I was very, very focused machine-generated data. And that's what led me to my focus on IoT. I will tell you, in all honesty, I became very passionate about IoT. And I currently sit on the board of the Illinois Technology Association as well. And the ITA is based in Chicago. And because I was so interested in IoT, I worked with the people at the Illinois Technology Association to start an IoT summit back in 2013. We did that in 2013 and 2014. And then in 2015, we actually formed the IoT Council. So the Midwest IoT Council has been in existence since early 2015. And I co-chair that along with my good friend, Brenna Berman, who's the former CIO of the city of Chicago. As a side note, I'm also on the executive committee of the Array of Things project, which is a Department of Energy run NSF grant project for smart cities. And it's really being driven in Chicago, but there's 40 other cities that are lined up behind it to do that. So I am very active in the IoT community, and I'm very passionate about IoT. Okay, so with that, let me just dive in here. So let's talk a little bit about IoT. So back in 2012, 2013, you started to hear about all these sort of new IoT things. So I could get a smart home, or I can have a Nest thermostat, or I can understand when my garage door is left open, and I can control it from my iPhone. And as we began to see more and more IoT enabled products, there was this kind of growing cool factor, and everybody thought, okay, this is great, and it is. And there's nothing wrong with the initial products per se. And they were kind of opening our eyes to where this new world was going. So whether it's a Fitbit or a Nest Cam, or from an industrial standpoint, whether it's an instrumented restaurant or an instrumented factory or whatever, we were starting to figure out that by putting sensors on devices and understanding the state of those devices, we can do things that we weren't able to do before. And I think everybody slowly but surely began to figure this out, and that seemed like a cool thing, and arguably it was. Okay, but there was one thing about that phenomenon, and that is most of these were based around some fairly old concepts, and old concepts mainly meaning from a data standpoint, and most of what you're going to hear me talk about it is really going to be data centric. The concepts were really around the silos with the data. So the super cool technology that was instrumenting the smart refrigerator was going back to the refrigerator provider, and the the instrumented turbine was going back to the turbine provider, and the HVAC was going back to the HVAC provider. Didn't make it any less cool, and didn't make it any less useful in and of itself. It just meant that the creation of the data was tied to the consumption of the data. And so that's how the basic systems were formed. And so the way I would characterize this is what you saw were basically closed loop message response silos. And again, nothing wrong with this. This was sort of the progression of IoT. And I'm going to talk a little more about this later, but Michael Porter and Jim Heppelman published an article in Harvard Business Review back in late 2014, and they talked about the progression from products to smart connected products to product systems to system of systems. And if you think about that progression, IoT really was the introduction of smart connected products. Connected via the internet, and fundamentally, most people that were in the IoT world back in 2012 and 2013, 2014, and certainly there are exceptions to this. There's no absolute, but the vast majority of the people that were in that business per se were focused mostly on this model. So the sensors would be on the device. The sensors would flow in through some mechanism, most likely some kind of a SIM card or whatever, into a cloud-based repository where there were a rules engine or a workflow engine, and that would do alerting and triggering. And that was fundamentally how most people thought about it at first. And again, nothing wrong with that. It was nice to know that the equipment was going to overheat or something was left open or whatever. But I used to have all these, because my focus was data, I would have these conversations with a lot of the different IoT providers. And what the conversations were really focused on was, but what about the data? How are you leveraging the data? And most people didn't necessarily have a lot to say about the data. They were mostly interested in the alerting and triggering. But the more we had the conversation, the more that made its way into a progression of the conversation where people would say, oh, the data is really, really important. But when either the product providers were talking about the data, or my friends in the technology business that were providing technology to enable the product providers to IoT enable their products, when people started talking about the data, what they really were talking about wasn't breaking down the closed loop silo as much as it was beginning to store the historical or persist the historical data and start to do things like predictive maintenance. Now we're hearing a lot about digital twin right now, and I'm going to come back to that in a bit. But in the earlier days, it was more rudimentary than that. People were storing the data so that they could begin to do basic analytics against it. And really what I heard one vendor characterize this as the holy grail was predictive maintenance. And I would argue that is not the holy grail, but it's an important part. And again, if this picture was good, then this picture is a better step in that direction. And so people started to talk about the data, but it was a relatively unsophisticated view of the data in terms of it's still pulling data off a closed loop message response silo. So far so good. So then an interesting thing started to happen. So Cisco came out with the whole fog computing architecture, and you began to hear people talking more and more about the edge. And there were a lot of companies out there that were really already doing this. And some of these were really byproducts of the whole M2M world, where there were certain characteristics of IoT environments that began to emerge. One of those is this whole notion of data exhaust. So let's say, for example, you're in a room, and everybody probably gets this, but it's probably worth at least noting. So let's say you're going to instrument every room in this building that I'm in. So let's just say there's 2,000 rooms in the building, and every room has 6 different sensors in it, and we're taking a reading once a second. At the end of the day, what's going to happen is the ratio of inconsequential to consequential data is going to be astronomical. And whether, people will throw around things like, well, communications are cheap and easy and storage is free or whatever. Well, at scale, that's not entirely true. And in fact, at scale, it really isn't true. And moreover, when you begin to think about some of the implications of processing and analyzing data, it is actually very important to understand the architecture and what you're asking various components of the ecosystem to do. So if I have 100 or 1,000 times more data than is going to be useful for what I'm doing, I don't want to spend more money to push all of those messages into a cloud where I increase my cost of creating that flow. And at the same time, I'm actually reducing the value of the payload. So people began to realize that for that and many other reasons, there are a lot of reasons why you want to start pushing some of the computational work to the edge. So I may want to do I may want to do closer in workflow and filtering. I certainly am going to want to do filtering in terms of the data exhaust. I may want to begin to create derived fields and imputed information from the data coming off the sensors. And I may want to create those alerts and triggers closer to the point of ingestion. So the whole notion of edge computing began to become more popular, and with good reason. And so architecturally, you began to see this whole notion of, in some instances and for some applications, putting an edge processor close to the point of ingestion. Okay, now this is where it gets interesting, because I believe that a natural extension of this is a key component in the overall architecture. And when I say a key component, I mean it's a key component because at some point we tip the equation to providing an enterprise to vastly enhance their leverage of the data. But to do that, you have to think about this from the lens of the user of the IoT systems and not the product provider. And so I would argue that at the edge, we start to need to look at what I would characterize as a first receiver. And we started using this term, or I started using this term to characterize the architecture several years ago. Since then, there have been a few things in the market where you may or may not have heard this term, but it's being used more and more. And it begins to speak to the role of not only the computational work at the edge, but persisting the wider scope of the IoT data that sits, in a certain location, and creating an enriched data model that's persisted and stored for both local use and also propagated via certain governance and administrative controls to the right constituent in the right time in the right way. And we're going to come back to this, much more, but fundamentally, this is the sort of the pivot point in the architecture. So the whole role of the first receiver is to create an architecture where you can create maximum leverage of the data. So I'm gonna come back to that, but let's just move on for a second here. So to illustrate this is a hypothetical, and I use McDonald's just because that's an illustration that people around the world will know. I'm not suggesting that this is McDonald's plan by any stretch of the imagination. This is a hypothetical. But just think of a fast food restaurant, and the fast food restaurant might have a lighting system and a kitchen equipment system and a beacon system and an HVAC system and other things. And fundamentally, where the way this would look in most instances, certainly 2 years ago, and most likely today to a large extent, is that the IoT-enabled product data goes directly to the IoT-enabled product provider. And the enterprise, in this case, this would be McDonald's, the enterprise basically gets to see that information that the IoT product provider suggests they can have. So it's really the ownership and the stewardship and the governance of that data really is not in the hands of the enterprise using the IoT products as much as it is in the hands of the product providers. But my thesis is that will have to change, and mathematically it to me is impossible that it won't change for the following reasons. Let's just use this example. If you're the owner of a number of different fast food franchises, or you're the CIO of Walmart or Sealand or Disney or whatever, and let's say 3 years ago you had no IoT enabled products, so you had an HVAC system or you had a lighting system or whatever, and then slowly but surely you start to add these IoT enabled products into your enterprise. And 18 months ago you've got 5 or 6, and 12 months ago you've got 20 or 30, and 6 months ago you've got 50. And you're thinking to yourself, I'm pretty smart. I am a forward thinking CIO, and I've really thought about leveraging all this IoT enabled equipment, and I have a modern environment that is taking advantage of the new world of IoT. And then you walk in 6 weeks ago, and it dawns on you that you'd like to see the low-fat fryer data in the context of the grill data and the freezer data and the HVAC data and the lighting data. You'd like to see the IoT data in the context of the other IoT data of the IoT-enabled devices you're using. And when you do that, you can start running correlation analysis that you wouldn't see otherwise. And that can tell you more about what you're doing. And then it dawns on you that if you would take that and marry it with your point of sale or your crew scheduling or your inventory system, that's going to reveal even more. And then you realize that if you can then also import external data, whether it's pedestrian traffic or street traffic or micro weather forecasts or whatever, or even events in the area. So I know that maybe there's a Giants game that is about to get out, and I know that my pedestrian traffic is going to increase. All of this external data and internal enterprise data and IoT data collectively make a much, much richer signature. And you, as a smart CIO, recognize that there's leverage to be gained and increased insight from that data if you can get it in the right way at the right time. And so this silo-based approach isn't what you want. Now, I had this discussion over and over and over with people in sort of the 2014, 2015 timeframe. And every time I would talk to somebody, I would get a very positive response, but I noticed a pattern. And the pattern was I'd have this discussion, and then I'd have the same discussion 3 months later, and the people I was talking to would seemingly not recall anything I had ever said. And it could be poor delivery on my part, which I certainly hold open to be possible. But the fact of the matter is, this is something that I had been thinking about over and over and over, literally for years. So it was going to be much more natural for me to get it. But my friend Mario, who is with an IoT platform provider, one day said to me, Don, what you don't understand is that most of the people you're having this conversation with don't have data DNA. They're hardware, they're sensor people, they're workflow people, but they don't have data DNA. So what you're saying makes sense to them to the extent that they get it, but they just haven't spent so much time looking at data. And in fairness, I didn't have the sensor or the communications DNA in me, and that really was required learning curve on my part. But I was frustrated because I thought the concept of leveraging the data was going to be at the heart of driving value for IoT, and it wasn't resonating. Which brings me to Eli Goldratt. So this person you're seeing is Dr. Eli Goldratt. He's an Israeli physicist, and he had this manufacturing scheduling system back in the early 80s called OPT, and it was based on the theory of constraints. And in the US at the time, there was this whole idea that if you had all this expensive capital equipment in your factory, you really needed to utilize it, to pay for it, to make sense out of the acquisition, out of the investment. And so people would try to make sure their factories were fully utilized at all times. And Dr. Goldratt basically came out with a manufacturing scheduling approach that said that, based on the theory of constraints, that said that isn't how you should do it. You should actually use a different algorithm that will, in essence, tell you not to run some of these very, very expensive machines at certain times, because that's not what you're not after utilization. You're after the proper output matched to your forecast. So this software was telling the plant managers to do what was counterintuitive to them at the time. And so what happened was they didn't, and it was like the plant managers didn't have that DNA. And what happened was they started to override the what the system was telling them to do, and everything got screwed up. And then they blamed Ellie Goldratt because they would say that your software isn't working. Well, the software was working fine. They were just neglecting to follow the recommendations. This, of course, frustrated everybody. And so Ellie Goldratt encountered the same thing, which was he was trying to convey something, but having difficulty getting people to grok what it was he was talking about. So he found this guy named Jeff Fox and basically decided he would write a book to explain the concept. So he came up with a narrative that really discussed the theory of constraints. He wrote a book called The Goal. And this almost had a cult-like following, but it was really a narrative that explained the theory of constraints with the idea of getting people to begin to understand what it was he had been so frustrated in trying to convey. Now, when I thought about this after the time that I had spent trying to have this discussion, I had an epiphany. And the epiphany was to follow suit with Dr. Goldratt and write a book. And I thought, well, this is obviously the thing I should do. I mean, it worked for Dr. Goldratt. Why wouldn't it work for me? And there was one clear answer to that. And that was, I really didn't know how to write a book, which in the grand scheme of things was a limitation. So, and apparently I don't know how to build my slides. So what happened was I started this and ripped it up several times, but what I was really trying to do is convey the thesis around the first receiver. So I began working on this and ripped it up and began. And in 2016, I had finally settled on a framework that I thought worked. And I was at Mobile World Congress in Barcelona in February of 2016, and I shared this with a friend I had met from Makina Research. And Makina was a specialized IoT consulting firm, and his name was Emil Berthelsen. And subsequently, Makina was bought by Gartner, but Emil, while he was still with Makina, basically I walked him through the thesis, and he really got it instantly. And he came back and asked if I was okay with him publishing a research note to all the subscribers, saying I'd like to tell all of our enterprise subscribers to look at the first receiver architecture. And he did that. He did a marvelous job of that. And so I actually decided, maybe if I enticed Emil to work on this with me, I would have a partner in this effort, and we would hold each other accountable, and we would actually finish it. And that actually did happen. And then towards the end, Emil reached out to me and said he wanted to bring on Wael Arifi, who was a good friend and an executive at Hitachi Vantara. And Wael actually brought some use cases and user perspective to the equation. And it took us forever. But in May of this year, we published this book, The Future of IoT, and it is about the very shift that I'm talking about. So now I'm going to dive a little bit further into this. The shift is about the market forces that's going to drive the enterprise. And those market forces are formidable. And I go back to the discussion about the Michael Porter and Jim Heppelman article from the Harvard Business Review. And this was the graph from that piece. And most of the market has largely for the last couple of years been focused on smart connected products. And in the first part of this progression, it's really all about how do you make the product providers IoT enabled? How do we deliver smart connected products that our customers are going to love? And again, there's nothing wrong with that until you start to figure out, how do I gain the maximum leverage from the data? And in doing that, the focus shifts to the enterprise. And it's really, how do we effectively leverage all of these smart connected products? And therein lies the key part of the overall equation. And the way to leverage the smart connected products is entirely through the architecture. And again, we call this architecture the first receiver. So go back to our silos. So in this hypothetical, what you have when you're dealing with this is an organization that is a user of IoT enabled products. But what you really want is to become an IoT enabled organization. And what that would look like here is this whole idea of a stage in the middle, really close to the point of ingestion, that is capturing and persisting and cleansing and enriching that data, and then applying the governance as well as the security and the privacy considerations in order to propagate that data to the right constituent in the right time in the right way. And so let's look at this. If you're doing this way, there's nothing to prevent you from capturing all of this data and persisting it into a master data store, but then using the right governance tools, pushing that data, for instance, to the product providers. So the HVAC vendor or the lighting vendor that was getting that stream before can still get the very stream they had. But now I can also push the data to my regional or corporate offices, and that's going to look different than what I send to the HVAC vendor, because I'm going to send the HVAC vendor the HVAC data, but nothing else. I'm going to send the lighting vendor the lighting data, but nothing else. But I'm going to send my regional offices or my corporate offices, something that looks like a much broader view of the data. And then there are other third parties like supply chain partners that may want information on inventories or lots of things, or people like regulatory bodies. So the time will come where the FDA or OSHA, or various regulatory bodies are going to realize that they can do their job much more effectively by embracing IoT. And in doing so, they're going to want that same data. And what is that data? The temperature reading that they're taking off of the HVAC unit is the same message that's being sent to the HVAC vendor or to the regional or corporate offices or to the supply chain partners of the FDA, but you're just abstracting the creation of the data from the consumption of the data. By the way, another constituent is going to be the local franchise, where they're going to be optimizing the operation of the local franchise with a whole set of apps. And by the way, this is gonna pave the way for an entire raft of new applications that currently don't exist, and in many ways we're not even contemplating yet. But architecturally, this is opening up the door for maximum leverage. Now, the other thing, and I know I'm spending a lot of time on this slide, but the other thing that's really important about this is that the product providers, in many ways, are going to push back on this, because, and the answer to that is a little obvious. Why would the product providers not want this to happen? Well, I'm sure most product providers, and with good reason, think that since they IoT enabled their lighting system or their HVAC system or their turbines or whatever, it's creating added levels of service, stickiness with their customers, and loyalty that they don't want to give up. And so they're gonna basically push back and say, well, thanks, but you don't really want to do that because we know more about HVAC than you possibly could. So you want us to be really the ones dealing with that data. And the answer to that is, as an enterprise, let's just say you're the CIO of Sealand. You're going to want the product providers to have that information. but not at your expense. You want to be able to persist and leverage that data, but you still want to give that stream to the product providers because you want them to do all the analysis and predictive analytics and what they're doing that they're already doing. Makes complete sense, but again, not at your expense. But the product providers probably aren't going to like that. So they're going to say, well, you don't really want to be in the firmware business, and there's a lot of firmware associated with this. And the idea there actually doesn't hold a lot of water because device drivers have been around forever, and anybody who has a printer hung off a laptop knows that device drivers are something that are time tested. And so the fact of the matter is the architecture should be able to support this rendering of how the data can be leveraged. But here's where the tables should turn. So I wouldn't blame the product providers for saying, no, we want to keep the flow of data the way it is. But two things are going to happen. Number one, if you are a large organization and you're going to buy a new lighting system and you look at 10 different lighting vendors, if 6 of them are willing to let you have much more control and ownership of the data, provided that they get the stream of data they want, but 4 of them are not willing to relinquish that, then your short list of who you look at will go from 10 to 6 immediately because you recognize the value of that data. So the market demands are going to create table stakes for the product providers to need to provide these capabilities. But if the enterprises are smart, and now this is back to you as the CIO of Sealand or Disney or whatever, if the enterprises are smart, they're going to say, look, this is what we expect in order for you to compete for this business, but here's what we're willing to do. We'll give you back your stream of data, but we'll work with you to give you back that stream, but also contextualize. So we'll give you what those micro weather forecasts were, or we'll give you some of the other corresponding information to enrich the stream that we're giving back. So now you can do an even better job because you're getting better data. And again, this just gives way to the entire thesis around really maximizing the leverage of the data across the spectrum. The whole idea here is that, and the point I'm trying to make here is that nothing that I'm saying about this architecture is new or earth-shattering. Architecturally, what I'm suggesting has been around for years and years and is time-tested. It's just looking at IoT through what is a new lens, but it's not a new lens. It's the lens of the enterprise by employing traditional techniques that are time-tested, but it just inverts the way the data is being treated today. But again, this is going to have to change because the market is going to demand this. So when I say everything old is new again, what do I mean? Well, for starters, I mean the imperative for leveraging the data is separating the creation of the data from the consumption of the data. And therein is where you drive much, much, much greater leverage. Now, is this a new topic? It is not. The man in the forefront of this picture is Dr. Frank King. This was my company that I ran called Larry from 2002 to 2010 was a complex event processing company. And this was our advisory board. And Frank was also on our board of directors. Frank led the System R team at IBM in 1974 that really pioneered relational databases. And I'll never forget, I was in a board meeting early on, and Frank basically said one of the key concepts that defined computing and the leverage of the data is leveraging the utility value of the data. That's what relational databases were all about. Well, that's what the first receiver concept is all about. And I think when you think about IoT, IoT is this massive technology wave. It's arguably going to be the most important wave in technology we've ever seen, even more than the internet itself. But most analysts would agree, and when I say most analysts, I'm talking about ABI or Gartner or Harbor or all of them. Most all of them agree that the vast value of IoT is going to be the leverage from the data and the insight from the data. And the insight from the data is going to be just absolutely higher if the architecture is delivered in a way to leverage the utility value of that data. And the other concept is that it's really going to look, in most cases, to be a publish and subscribe architecture, where again, this is shown as two-tier, but it can really be a multi-tier architecture. And at every tier, there will be the capabilities of doing workflow and filtering and applying governance, but also the whole notion of digital twins that really are analytic workbenches. So from an operational or investigative or predictive analytics standpoint, when I can enrich and cleanse and enrich the underlying data store, it gives me an increasingly better opportunity to do operational analytics where I'm answering the question, what's going on? So my traditional things like BI tools, like MicroStrategies or a Cognos or a Pentaho, these type of tools with much more granularity are giving you greater insight as to what's going on. But then there's the operational, the investigative analytics. So forensic analysis, root cause analysis, where I'm mining through the data to try to understand why is it going on. And then, of course, the predictive analytics to figure out what will be going on. And then ultimately, what I believe is the holy grail of IoT is going to be machine learning. So if you look at the analytics stack that creates the opportunity for the virtual representation of a given asset, which you'll hear a lot more as we go forward about digital twin. The biggest part of that equation is really machine learning, because that once you get to that, it's almost the emulation of a living organism. You get to truly adaptive systems, and there are certain IoT elements that we don't want to engage until that is capable. Autonomous driving would certainly be a good example of that. So if you're in a self-driving car, I'm pretty sure you want it to be adaptive to the circumstances around you, or else the likelihood of crashing will be significantly higher. But these concepts are not new. The whole machine learning's been around for a long time. It was just never quite as important in the equation until the underlying data stack was as meaningful as it's getting to be. Certainly, business intelligence and operational analytics, exploratory analytics, and predictive analytics are also concepts that are not new. So data is the key. And when you think about everything I've been saying, all of this is focused on how do I get the maximum leverage from the data. Maximum leverage really means maximum value. And when I can do this in a way that allows for maximum leverage to all constituencies in the ecosystem, then everybody benefits. And another thing is security is a key element. So we recently sold our company in May. And since then, I've actually aligned myself. I joined the board of directors of a security company called Sentry, and I joined the board of advisors of a privacy company called Ananos, and a governance company called Microshare. And I think, and this is part of my sort of journey to find best-in-class elements of the fundamental stack that I think is key to the leverage. So security, I have a friend named Chris Resendez from INEX Advisors, and an amazing guy. You should go on YouTube and search for Chris Resendez, and he's actually a partner in the new book that we're working on. And he said something at the keynote address at our IoT Summit recently that I thought was amazing. He said, people talk about data is the new oil, but trusted data is the new oxygen. You can't live without it. And so security is really key. Privacy is also really key. So when it comes to trusted data, and there's all this concern about, will all this data fall into the hands of an oligarch of, 8 different companies, and where will the leverage be and where will the resilience be? It's really important that the security and the privacy elements of this equation are addressed. And this whole architecture is actually incredibly good for addressing that. The architecture is really critical. The architecture is the enabling piece of the equation to deliver on the promise of IoT. And over time, there are going to be things like, and this is probably a little farther down the road, but the whole notion of using things like statistical models to create metadata where your footprint is maybe 1% of what the atomic data would be, but it's queryable as if it was the atomic data so that you can do things faster and more efficiently at the type of scale that IoT ultimately will reach. But the architecture is the critical piece of the equation, and that's what's important in terms of leveraging the overall data across the ecosystem. And so at the end, what you're after is maximum leverage from the data while ensuring the right security and privacy. And if I could encapsulate it in a nutshell, it would really be, we have to go from thinking like a user of IoT-enabled products to thinking like an IoT-enabled enterprise. You have to view the where the world is going from the lens of the enterprise. And when you do that, this architecture starts to make more and more sense. And our belief, I say our belief, my belief, Emil's belief, Weil's belief, and certainly many others that I have interacted with, including like the folks at Microshare and Ananas and Sentry, I think would agree that in the end, that architectural approach to delivering maximum leverage to the enterprise, it will ultimately prevail. And we believe that is and I say the near future of IoT, because I think that in the next 2 years, we'll see this progress very, very, very quickly into that world. The further future of IoT is a higher level discussion on resilience and the democratization of data and where we go as a planet, which is a kind of a big thought. And I'm not going to, I'll do you the favor by not going down that path right now, but it'll be an interesting subject. But right now, I do think that the near future of IoT really is to move towards the system of systems, as Michael Porter and Jim Heppelman cited in their 2014 article. And in doing so, you have to look at this from the lens of the enterprise. And in order to do that, you have to have the right architecture, which I think is what we've discussed here today. So I appreciate that. With that, I'm going to flip back to the webcam to see if there are questions. So finding people have complete information about the sensors and connecting to the internet, which also involves domain knowledge about the sensors. Yep, surely does. And how to connect to the internet. Data analysis and storing data is easy. It is. Doing it right isn't always as easy. What kinds of specific technologies and implementations would likely be involved in this fog edge area? What kinds of responsibilities would it specifically have? I think the question that is being asked is at the first receiver layer, at the fog edge area, what type of technologies would be involved? It's a great question. And what kinds of responsibilities would it have? Okay, so it would be a number of things. It would be, first of all, it would be the protocol translation. A typical edge device is going to do certain things. It's going to ingest the data, and the sensors may be coming in off a variety of different venues. So it may be a CAN bus. It may be linked through even some SIM card. It doesn't even have to be physically linked. It can be doing coming over wireless. There are certain technologies emerging from a communication standpoint that are going to be really, really key technologies. Low power wide area networks being the most obvious of those. But the first receiver, the edge is going to do things like do the protocol translation to get the data into a format that's understandable at a common level. And then certain types of computational work at the edge. So that would involve, programming on the edge that would be doing alerting, filtering, or whatever. And it could be a variety of different tools like, Spark or Spark streaming, or it could be proprietary tools. I think more and more you're seeing from a software stack standpoint, you're seeing more and more of a progression into a lot of the sort of Apache ecosystem open source tools. But those are kind of the edge elements. And by the way, this I go into a lot of detail in the book, but those are the basic edge elements. But then when you add the first receiver elements, that would be persisting the data into a locally persisted database, which actually can either be physically or virtually represented. The first receiver doesn't have to be physically instantiated into sort of an industrial edge device or whatever. It can be, a distributed Amazon cloud or whatever. But there would be a persisted data store, and there would be certain types of governance capabilities. So things like a microshare, for example, that would provide for the governance. There would be privacy. There would be security and privacy elements. The security elements would extend all the way back to the sensors themselves. That would be something like a Sentry. There's a ton of different security solutions out there, but what you want to make sure is that your security ripples from chip to cloud. And then certain types of privacy elements that as we go towards things like the GDPR regs in Europe, and I know some of you are probably on from Europe, those are a huge deal, especially since the fines are so unbelievably enormous. And so there are certain requirements for anonymization. There are actually safe haven elements under the GDPR regs that allow for a different treatment, provided that you comply with the 99 articles of GDPR. The company Anonymous has patented technology around what they call dynamic pseudonymization that allows you to actually relink the context instead of losing it forever when you anonymize under certain conditions. So again, there's a lot of clever people responding to market requirements in different ways. But the governance and the security and the privacy would logically be handled at its most important point in the ecosystem at the first receiver, where it's then propagated to the right constituent in the right time in the right way. So those are really the functions at that tier. So I see I have another question. Could that be a cluster for a specific? Absolutely. Could it be? So the question is, could that be a cluster for a specific region of McDonald's that interfaces with the larger McDonald's cloud network? Again, using McDonald's as a hypothetical. I'm not trying to represent what McDonald's is doing. Regarding enabled devices, or would it specifically be classified as these GPU-driven machine learning hardware elements like NVIDIA Jetson? No. And again, I'm not trying to push the book, but I go into much more detail in the book about this. But just from a deployment standpoint, there can be a 1-to-1 ratio between the edge device and the first receiver elements of the edge, or the first receiver elements in general, the persisting of the data, the manipulation of the data, so the aggregation, the filtering, whatever, and the propagation of that data out to the right constituents. But there doesn't have to be. So, for example, using the McDonald's as an example, let's say I own 10 franchises, and I want to put an edge device that's doing the traditional edge processing, the computational work, the protocol translation, things like that. But then I want to push that into a first receiver, but I want the first receiver actually to have a consolidation of 10 different stores into one first receiver persisted layer. That absolutely can be done. So there's all kinds of flexibility in the architecture, but the goal of the architecture, again, is to give maximum leverage of the data both to the local users and the local operation, as well as to any constituents related to that local user. And the constituents should only get the data that is appropriate to them in the way that is appropriate to them, including the certain anonymization or pseudonymization of the data to comply with privacy laws. But that you want to get them the right data securely and appropriately. And a lot of times that's going to be a subset, including certain imputed information from that baseline data set that is facilitated by that architecture. Okay, so here's another. So it sounds like both. If there are sensor responsible devices and the cloud, the devices responsible for trickle up data would be this edge fog space. Yeah, that's true. That's true. And again, you have ostensibly there's a lot of flexibility in this. And the other thing I would say that is noteworthy is there are a lot of horizontal IoT platforms out there. probably like 700 of them. There are not going to be 700 winners, just like there aren't 700 Googles. There's Google and Yahoo and a few other search engines. But in 1996 and 97, there were a lot of other people that were just as good. Hey, we're going to be the next Google. There aren't going to be 700 IoT platform ones, but because the domain specificity is important in the equation, there's probably not going to be one or two. There's probably going to be 8 or 9 or 10, but again, not 700. But what I would say is important, and I'm not going to start calling out specific IoT platforms as winners and losers here, although I certainly do have my opinions. But the one prerequisite I think is going to be there for the winners will be ones whose architecture is extensible for the enterprises to leverage those architectures for this type of capability. So in essence, it will have first receiver-esque elements to it that are going to look like a publish and subscribe architecture where the control of the data and the persistence of the data can rest near the point of ingestion by the enterprise itself, and yet the governance capabilities will exist for the propagation of that data in the appropriate way. And I think we're likely to see that. And there are already numerous IoT platforms out there. Some articulate this better than others, which I think is kind of a crack up, because if I were some of these that have the capabilities inherent to what they're already doing, I would be messaging that in a strong way. But again, we're just seeing the shift in the market, but the shift is going to happen more and more and more. And so I think we will see this. I'm actually very confident of that, but it's great. And the end result for all of this, and I know this is going to sound like I've walked out of the cult, but the end result is a better world. Like when we leverage IoT effectively, we're delivering medicine to people who can't get it. We're delivering resources in a way that make this a more sustainable and resilient world. It's all good, but it has to be leveraged appropriately. So with that, I certainly want to thank everybody. I hope you've enjoyed this. I know I have, and good luck with all you're doing. So long.